For over a century, physics has modeled the universe as a smooth, continuous fabric, a seamless sheet of space and time that curves under the weight of stars and galaxies. But zoom in far enough, and that fabric fractures. Space and time are actually built from discrete, quantized packets, pulsing across a rigid geometric lattice. This structural mismatch creates a persistent problem. To make the standard models of quantum mechanics and gravity function together, physicists have to manually insert dozens of arbitrary numbers, free parameters that lack an underlying explanation. The brightest minds of the 20th century attempted to unify the microscopic quantum world with the macroscopic universe, yet they remained limited by these incomplete mathematical workarounds. Unified dynamics takes a different approach, deriving reality entirely from a single irreducible geometric shape, the K4 tetrahedron. In this framework, the laws of physics are not guessed. They emerge as the inevitable geometric results of the tetrahedral structure itself. To understand how this works, we have to look at the mantra of the void, which defines the absolute bottom layer of reality. The first part of the mantra states, "The field is the zero." This zero is not an empty absence, but a governed balance, a highly structured state of equilibrium. The second part is, "The dynamics is the recursion." The universe computes itself through an iterated function system, endlessly feeding geometric configurations back into themselves to test for stability. Physical reality is the fixed mathematical output of this continuous recursive process. We can see this mechanism in action by looking at the F6 lattice simulation. This diagram shows the simulation ticking through the lowest fractal levels, n equals 1 through 4, as the geometry rapidly shifts. These early layers are defined by instability. The edges fail to close, and the geometry collapses in on itself. At level n equals 5, the geometric density increases, but the connections remain too fragmented to support a lasting structure. At this level, the network faces a hard threshold. Without achieving a specific degree of connectivity, the recursive engine cannot carry the state forward, and the configuration dissipates. Then, the simulation finally reaches level n equals 6. The chaos instantly snaps into a perfectly symmetric geometric configuration. This is the pre-generational vacuum, a phase defined by perfect Z3 mathematical symmetry. In this state, there is one three-fold symmetric generation, but no matter and no gravity yet. It is a stable void waiting for a structural breaking point. The recursion ticks forward to level n equals 7. This is the point of geometric inflection. That perfect Z3 symmetry shatters, fracturing the single vacuum state into 3 distinct topological families. Look at the closure metric. The structure achieves a persistence rate of exactly 94.07%. This achievement of stable, self-referential closure in the lattice packets is the Big Bang. Because this high closure rate allows the K4 structure to persist across iterations, it generates a clamping effect, the fundamental origin of gravity. As these loops lock in place, the computational noise condenses. These stable transport inconsistencies, frozen by the connectivity of the lattice, become the first packets of matter. Recognizable spacetime is now a direct output of the tetrahedral network. The Big Bang was not a random explosion, but the exact moment the universe reached a mathematically inevitable combinatorial threshold. Because the universe achieved stability at level 7, the laws of physics are set by the K4 geometry. This is the universal structure theorem. This dashboard tracks the Unified Dynamics Scorecard, comparing the framework's internal calculations against real-world observations. The geometry naturally accounts for several observed constants, exactly 3 dimensions of space, and exactly 3 generations of matter. It derives the cosmic microwave background spectral index at exactly 185/192, and the fine structure constant at 7/960. The framework provides 28 exact predictions with 0 free parameters, suggesting the universe built itself without external tuning. These subquantum predictions provide an alternative explanation for anomalies observed by our most advanced facilities, such as the high redshift galaxy data captured by the James Webb Space Telescope. Deep underground, the IceCube Neutrino Observatory is currently acting as a testing ground for the structural oscillation anomalies predicted by this lattice. The geometric rules of the tiny K4 tetrahedron dictate the structure of the largest superclusters in the cosmic web. Gravity, gauge forces, and quantum mechanics emerge not as separate rules, but as the inevitable echoes of a single mathematical truth: the architecture of time.